Welcome once again to the part 2 of our discussion on nutrition. I am your presenter, Edward Asante-Akuffo. In our previous lesson, we looked at how to identify the elements in food substances that we consume. We also explained how these elements in the composition of food nutrients combine to form organic compounds. In today's lesson, we will first of all demonstrate how reducing and non-reducing sugars are tested in the lab. We will also state some uses of carbohydrates to living organisms, that is plants and animals. Again with me to have this discussion is Mr. Kingsley Asiedu. And on my extreme right is Mr. Asiamah Kuffuour. By the end of this discussion, you will be able to demonstrate how reducing and non-reducing sugars are tested. And last but not the least, state some uses of carbohydrates to organisms. Okay, Mr. Asiedu, let me turn to you.
Okay.
Please take us through the physical characteristics of carbohydrates, please.
Okay, so we'll begin with the simple sugars.
Okay.
Now, if we take the simple sugars, we are looking at the glucose, the fructose, and the galactose. And basically, they are colorless, meaning that they don't have, just like water. Water doesn't have any color, so they are colorless. You don't say they are white, they are not white. Yes. They are colorless. So we talk about them being colorless. They are also soluble, meaning that they dissolve in water. And then they crystalline, meaning that if we have high concentration, solubility, more or less solubility, they also form crystals. Now, they are the main source of energy. For example, for respiration of glucose, it makes energy of food available for use by the body. Okay. Now, some sugars are stored as glycogen in the liver and a little in the muscles. Okay. Now, glycogen acts as a glucose source when blood glucose levels are low. Okay. So, for example, if somebody is fasting, the glucose concentration in the blood will fall, and we have the breaking down of glycogen into glucose. It's more enzymatic, so we talk about glucagon. Okay. So we have the hormone glucagon converting glycogen to glucose, so that the person will be able to survive. So somebody can survive for 40 days without eating, because once you have storage of glycogen, the body will be able to make use of the reserves. Now, any sugar left over are stored as fat. So we have fat or lipid also being stored. That's when you eat a lot of sugar, it will be stored as fat. So sugar consumption basically could also lead to obesity, because once you have fat deposits, then that could also lead to obesity. Now, complex sugars are white. That is, we are looking at the polysaccharides. Yeah. The polysaccharides, we say that they are white in color.
So you are done with the monosaccharides?
Yeah, we are done with the monosaccharides.
Reducing
yes,
sugars.
the reducing sugars.
Now let's get to the
for
complex.
the complex, they are white in color, and then again they are insoluble in water. So if you take if you take starch powder, they are insoluble. Yeah. Okay. Yeah, they are insoluble. So these are some of the characteristics of the physical characteristics of the carbohydrates. That is the simple ones, and then the complex sugars.
Okay. Yeah. Thank you so much. Now, at this point, we mentioned reducing sugars, non-reducing. I think we need to be able to prove to students how to test for these sugars, so that the students will be very clear in their mind, whether test or practical or real written paper. They will be able to come up with the procedure.
Sure.
Can you help us?
Okay, so we're going to demonstrate that on set. We're going to look at the simple sugars and the complex sugars, or we look at reducing sugars and non-reducing sugars. When we talk about the reducing sugars, you're looking at glucose, fructose, and then the non-reducing sugars, basically sucrose. Sucrose. We look at sucrose because the maltose and lactose are also reducing sugars. So we look at sucrose and then glucose for starters. So we're about to start the simple reducing sugar. We're using glucose, but we got the glucose from the pineapple, as you can see here on your screen. We have pineapple, fresh pineapple. We were able to extract the juice and made it in the solution of glucose. So we have glucose solution here from the pineapple. Okay. So we also have Felling solution as our reagent, and the color is blue. So there's a stopper in here. Blue. We also have our egg albumin. Then we have our lemon juice. Both will be used for control, or they will be used as control. Okay. We have our test tubes here. We have some test tubes also here, already labeled A, B, C, D, but we use A to C. We have our rack that after the experiment we'll place the contents of the test tube in here. We have our forceps also here. Once we'll be dealing with hot water, we need to hold the test tubes with a forceps so that we'll prevent burn or burning of the fingers or the digits. So we have this to hold a test tube holder. We have the test tube holder here. Very important. Then we'll talk about our setup here. We have our boiling water. We have our stand, the gauze, the gas also here. We have a cylinder containing gas as our source of heat. Good. So we'll take our test tube and then we pour in per the instructions or the procedure. We need to pick 2 cm cube of the reducing sugar. Here we are looking at glucose. So we'll just pour. We can just pour small amount, about 2 cm cube, about 2 cm cube. So let's assume we have this as our 2 cm cube. This is glucose solution from the pineapple. That is our A. Then we have our B to be the lime. So we have 2 cm cube of our lime. It's too much. Okay. Just let me add a little to it. Okay, good. So this is our content in test tube B. We have lime juice. Then we take our C, test tube C. The content will be egg albumin. So we have great. So we have our A, B, C. We have our A, our B, our C. I can now put away my reagents because I need some space. Then we add 2 cm cube to each of the test tubes A and B, A, B, C. We add 2 cm cube of the Felling solution, which I've already shown on screen. So we'll take 2 cm cube, same amount. I can decide to pick with this. Okay, let me just pour 2 cm cube. So we have 2 cm cube. I want you to observe. Initially, we had a colorless solution. Now the solution is blue. Very, very important. It was colorless. Now it's blue. We take that of B. We add 2 cm cube.